Right, good day and welcome. I'm Mr. Simons. I'm just looking at another set of Theorem 1 to Theorem 4 problems as asked in exam. So first question here is from November 2015, set up in the Eastern Cape. Question 9, and they say, in the figure below, DCO. So DCO equal 25 degrees. O is the center of the circle. Calculate with reasons. Size of angle D1 here, then they want the size of O1, then the size of A1. So as I say, this is just testing observation skills. The theorems you'll have to study and memorize, but slowly but surely that will stay in your head. New observation. As I said, I've used color to show you. Some of us naturally can see it, others just have to draw in some color and all of a sudden everything makes sense. So let's look at the solutions. So for the first one, calculate the size of 9.1.1 angle D1. So for D1, we should understand that OD there and OC there are called radii. They all start from the center, OB also. So OD and OC are equal in length. We should then understand that equal sides subtends equal angles. So you see, this angle 25 is opposite the side OD, and therefore opposite OC is D1. So D1 then equal 25 degrees. We say equal sides subtends equal angles. Hope that makes sense to you, no? Look at the second problem. Calculate the size now, 9.1.2 of O1. So we want O1 there. Alright, so we have D, yeah, that's 25. If I go back with T, the vertex T, see there, it ends by B there, and here it ends by C. So this angle T is subtended by this arc BC. If I take O1 there, and I go back, O to C, and O to B, that's also subtended by the same arc BC. So BC subtends the arc, or the arc BC subtends the angle O1 at the center and the angle at the circumference D of 25 degrees. So therefore, O1 equal 2 times angle at circumference. So therefore, O1 is 25 times 2, which gives me 50. My reason angle at center equal 2 times angle at circumference. Right, so I hope you understand. Let's go to the next problem. So, calculate the size 9.1.3 of A1. So we want the size of A1. Right, we have D1, which was 25 here. Again, if I look here, D1 here, 25 degrees. Go back and it's subtended by the arc BC. Right, if I take A1 there in blue, baby blue, also goes back to B and C. So A1 is also subtended by the arc BC. So BC subtends A1 and it subtends D1. Therefore I can say A1 equal D1, and my reason would be angles in the same segment. Right, so I hope you see that. Right, so they're in the same side of the circle and they're subtended by the same chord or arc. Okay, the chord BC is not drawn in there, so arc BC, and therefore angles in the same segment. They've always formed basically like a voting X here in the middle. So you should be able to see, but take note, they must be touching the circumference. Not here in the middle, and then I say angles in the same segment. Let's look at the second problem. Now this is from November 2015, paper 2, question 9. And they say in the diagram, O is the center of the circle, but take note, O is not there, it's just on the line. Diameter, so my diameter here would be LOR, subtends LKR at the circumference. Angle L1 here is 58 degrees. Apologies. Calculate with reasons the size of N2. Right, so they want the size of N2, LKR, R1 and N1. Right, so let's look at the solutions. Right, so first we have to calculate the size of N2, so we want the size of that angle. So if I look at the vertex N and I go back, N2 NK and NR ends here by this red chord, KR. Alright, what was given to me? This L1 is 58. If I go back with L1, it ends by K, it ends by R. So L1 is also formed by the same chord KR. So the chord KR forms N2 and the chord KR forms L1. Therefore L1 must equal N2. And my reason, angles in same segment. Right? So if L1 is 58 and N2 also 58. Angles in same segment. Chord KR subtends both of them. Right? Let's look at the second one. Calculate the size of LKR. Again, as I said, just some use of color and you see. Right, so LKR, that angle, if I go back, it ends by L, ends by R. So you should remember the line LR is the diameter. Ne? And the diameter will always subtend a 90-degree angle at the circumference, according to Theorem 3. So there, LKR equal 90 degrees. My reason, angle in semicircle, or I can say the diameter subtends a right angle at the circumference. Right, I hope it's visible for you there in color, red and pink. Right, let's look at this problem. Calculate the size of 9.3 R1. So now I want R1. There I assume you can see now I have a right angle triangle. Sorry there, my line didn't come out perfectly straight, but 90 degrees. So I can say now in a triangle, the three angles must always add up to 180. Ne? So R1 here would equal 180 degrees minus the 58 minus the 90 degrees. Ne? My reason, angles in a triangle, lot of teachers would say you must write equal 180, but you see the angles in a triangle equal 180 degrees. So it's technically written there. If I subtract R1, then gives me 32 degrees there. Right, so R1, 32, angles, the sum of the angles in a triangle. Last problem, now they want N1. So I just found R1, it was 32. If I go back with R1, it's subtended by chord LK. Ne? If I go back with N1, N1 is subtended by chord LK. Ne? So R1 and N1 angles in same segment. Therefore, N1 equal R1 equal 32 degrees. Angles in same segment. Right, so hope you understand. Hope you enjoy the lesson. Please like, share, and subscribe. Right? A lot more is coming.